So far we've been dealing in small amounts of data and discrete amounts of data. Like if you wanted to know a user's name, you would create a string called name, and then if you wanted to know their height, you'd create another variable called height and another one called weight, and so on. So you'd have like 3 separate pieces of data you were tracking. The idea of a structure is that you could put all 3 of those chunks of data into a single object, into a single thing that you could then pass around. Like if you wanted to print out their name and their weight and their height, you could create a function called print, and then you could send that one thing to it, and that one thing has all 3. It's like having a box that has the individual pieces of data in it. So that's what we're going to work on. I skipped a couple of definitions. Here is the syntax for declaring a structure. Up above main or in a header file or something, you're going to have the word struct followed by the name, and then you're going to list some pieces of data. So an employee might have a first name and a last name and a position and a hire date. Might have those 4 pieces of data. Probably have more than that. In which case, we have a string for the first name, a string for the last name, some kind of data structure to hold the hire date, and a string for the title. Something like that. So here's an example. A student class. And what we're tracking for each student is their ID, their name, the year, and the GPA. So when you declare it, no yawning, you'll make me sleepy. You have to put a semicolon after the final closing brace. And that's kind of a holdover from the C programming language. The struct names and classes, which we're going to talk about later, you usually call them with an uppercase. Right now, all of our variables that we have created, if we were following the conventions, we have named them lowercase letters. But in this case, the structure should have an uppercase letter. So let's launch Visual Studio. It's probably not out there since everything was reformatted. It's not down here. Just do a search, launch it, make a new project. I'm going to call this one Structures. And I should not have chosen what I just did. The default was completely wrong. Please stop. Okay. We ought to play with that though at some point, maybe next week. This is what will give us the ability to create a graphical user interface with buttons and fields you can fill in. But I chose the wrong thing. Close the solution. New project. This time I want it to be the same thing as it's always been before. Not a Visual Basic, but a Visual C++ empty project. I'm not going to call it Structures because that's what the last one was going to be. I'm going to call it Structures 2. Alright, and there we go. Right click, add new item, add. I wish my boilerplate was out here. It's not. # include IO stream using namespace std, unless you don't like to do that, which is totally fine by me. Int main system pause return 0. Alright, now we have all of our good stuff. So here's what we would have done in the past if we wanted to track those 4 pieces of information. We would have gone down in here and we would have made a first name variable, lowercase s. Oh, I'm going to go back up here and do # include string as well. Then we would have made another string for the last name. And then we would have made another number for another piece of data, like a GPA. and an integer for what year? Graduation year. And we would have had to fill each one of those in. And now don't type this. If I wanted to write a function that would print those out, I would have to make it accept a string. I would have to make it accept, I did it again. That's Java with a capital S. Capital S. Another string, and then the prototype for it would have to have a GPA, and it would have to have a grad year, and every time I went and decided I'd add new data to it, I'd have to go and modify my print function to have each one of these. It'd be much better if these were in a structure, so that that structure could be passed to the print statement. I'm going to delete that. I'm going to cut those 4 lines out, and I'm going to type struct. Let's get the syntax exactly right so I don't lead you astray. Followed by the name of the structure, student. And then I'm going to paste those 4 things. And then there should be a closing brace and a semicolon. Now let's write a data entry loop. Kind of getting in before we should. Nah, we're not going to do the data entry loop. We don't even know how to use the structure yet. Okay. When we want to use that student, we use the name of the class of the structure. I will waver between using those 2 things independently. I mean, because in C++ there is no difference between a structure and a class, except that in a class the members are by default private, and in a structure the members are by default public. And we don't even know what that means, but that's really the only difference, is what the default state of the members. And when I say members, I mean the variables. But along with variables, you can also put functions. We could attach some functions to the student class. But we're not going to do that yet. But let's make a student. Student S1. Now let's set the student's first name. Student S1's dot first name is equal to whatever you want. Sally. Student's last name so I typed S1.FName is equal to something, and then I typed S1.LName is equal to something. S1's.GPA is 4, and S1.GradYear is equal to 2016. Now the way we have done this in the past, if you wanted to do something else with a different set of data, we would have to reuse those variables. We'd have to set first name equal to something else and last name equal to something else. But since we have a structure that contains all that data, we could just create a new student like this. Not student. It sounds like a dessert. Student. S2. S2.firstName is equal to Joe. S2.lastName is equal to Jackson. S2.GPA is equal to 3.9. He's almost caught up. Sally. Except I put quotes around it, and it's a double, so then it's flagging it as an error, as well it should. I accidentally made it a string. There we go. Take the quotes out. S2.GradYear, and our projected grad year is 2017. Now we're going to write a function that will print out each student. So just print S1. We haven't written it yet. And print S2. We're going to have to go back in and add that function. Okay, I'm slowing down because I know I type fast. If you've gotten this much typed, go ahead and run it just to make sure you don't get an error, which you should because of those print statements. Darn, I'm going to comment out the print statements for now just so I can build it and run it to make sure I don't get an error. Okay, it doesn't do anything, but it ran. That's what I wanted to see. Did everybody get that structure typed in? Hopefully, and has everybody got the 2 students typed in? Are you getting pretty close? Next student, uppercase S. No biggie except we want it to match those words. Cool. All right. So we want to write a function that will print out those students. We could stick the print function above main. We could stick it below main. If we stick it below main, we're going to have to add a prototype. But is that a big deal? No, it's not. So the function is going to be called print. And what does it take as a parameter? It takes a student as a parameter. I'm just going to call it S. It's a good enough name. And now let's see out some information about that student. First name, colon. Tell you what. Let's skip that and make it easy. Let's just print out s.f first name, s.f name plus a space plus s dot last name, l name, plus a slash n. The only reason I'm not indenting it is so that I can get all that to fit on one screen. Now let's print out their GPA. I may get errors printing it like this. Yeah, I'm definitely going to. I don't know why I didn't use ENDL up here. I'm going to change that slash n to ENDL. And just to make it pretty, we're going to print out a line of dashes underneath the data so that we can tell where one student stops and the other student begins. This plus sign is totally wrong. So is that plus sign? In fact, everything I was doing, every one of these plus signs actually needs to be arrow, arrow. Sorry, I slipped on into Python and Java again. Change this plus signs to arrow, arrow. When you're done typing that function in, go and make a prototype for the function and put that prototype above main. Just copy the header of the function, that void print student s, copy it, go above main, either above or below the structure, paste it, and add a semicolon to make your prototype. I'm going to do that now, and then I'll scroll back down just because I want to test this to make sure it works. So I'm going to scroll up above main, make my prototype, which says void space print student s semicolon. Now I have my prototype. Then I'm going to scroll back down here so that the people who are still typing can see it. And I want to print my two students out. So I'm going to uncomment those lines I had where I printed the students. Right there. And there we go. I ran it. Not that you can see it because the print is teeny tiny. There we go. It printed it out. Sally Smith, GPA 4, grad year 2016, Joe Jackson, and so on. So now we are dealing in data in terms of combined chunks of data and not as individual pieces. And you can make structures that are extraordinarily complex. You can make structures that contain other structures. You can make structures that contain structures that contain structures, you know. You can add methods to structures. We could take this print code and make it part of the structure itself. But in my mind, once you put a function like this inside of a structure, it's no longer conceptually a structure. Instead, it's a class. Structures were invented in C back in 1970, and then the idea of attaching functions to structures did not come along until C++ in the late 80s. So when they came out with C++, they went ahead and gave that ability to structures, but really that's the idea of a class. A class is data, like we've already seen, but also functions that work upon that data. We could, I'm not going to do that. What I would like to do is to take this structure, this student structure, and this prototype, cut those out and put them in a header file. I'm going to get in trouble doing this. I'm going to try to make it work. So I'm going to come over here, right click, and do add new item and call it student.h because it's a header file. Select header file there and call it student.h. Paste that stuff. It's not going to like it because it doesn't know what a string is. So we're going to go ahead and do, # include string. Get those errors to go away. That wasn't good enough. Okay, fine. # include string. Why did I include stream IO? That's not what we normally include in our boilerplate. IO stream. Yeah, that's better. I'm being terrible. I'm not going to do that. In front of string, add std : std : I'm doing this to avoid putting the using namespace. You really should not put using namespace inside of a header file that might be imported by somebody else, because not everybody wants to use the namespace std because it comes with an awful lot of functions and variable names which they may not want to use. Okay, so now I have a header file called student.h. It's got my structure definition, and it's got the definition of this function called print. Go back to source and do this. # include student.h, but don't put angle braces around it. Instead, put quotes around it, like that. Now, it should still work. Hopefully, I haven't broken the code when I did this. Okay, I may have flown past that too fast. Let me pause this and walk around and make sure. So what we're doing now is we're modifying the header file so that it does not produce an error if it gets included more than once by a single CPP file. And so what we're doing is we're checking to see if this variable, this preprocessor variable, has been defined. The first time that you include it, it has not been defined. And so it will run all of this code. It will include all this code. But then after that, that variable has been defined. And since this says if not defined, well, if it is, it's going to skip everything from here to here. There's an easier way to do this as well with what's known as a Pragma statement. It sounds complex, but it's really easy to use. But now if I go back over here to source CPP, I'm not going to get an error by including student.h twice. It goes ahead and runs. Let me show you the way to fix it so that you don't have to do all of those changes. You just stick the word # Pragma once up at the top of your code. The preprocessor then goes and expands it and adds all of this stuff for you. If you have that there, you don't need to add those 3 statements. So it's a more efficient way of doing it. This is the C style way of doing it, and this is a C++ style way of doing it, or whenever they introduce the idea of the Pragma keyword. Last thing I want to do is I want to take that print function out. No, I'm going to leave it as is. Let's just continue with the lecture. Okay, here they are writing a structure called Payroll, which looks very similar to ours. It has an employee name, as an employee number, the hours that they work, their pay rate, and the gross pay. They create an employee, and then they ask for some information about the employee. Enter the employee's number, get the employee's number, and then they fill up the structure with that information. They use CIN to read into employee.hours. They use getLine to read into the name. We could have done all that, but instead we broke it up into first name and last name. We may as well modify ours to look like that, though. Let us add a function down here called getData, or getStudent, or inputStudent. It's going to return a student. That's its return type. And our thing is going to be called inputStudent. What it does is it makes a student, and then it uses CIN and COUT in order to get the information about that student. Since we're using getLine, we're going to preface each getLine with CIN.ignore to make everything work cleanly. Now let's see out a message, enter first name. Let's read that in. Okay, let's use getLine. Now I'm going to do this right so I don't fumble it. Yeah, getLine CIN followed by the variable name, which is student.fname. Then do the same thing for the last name. You could copy and paste to speed up the process. Enter last name. COUT. Wait, now use CIN. No, now use getLine to get s.lastname. Now we're no longer going to be using get line, instead we're just going to be using regular CIN and COUT. I could probably get away with not using dot ignore. Let's see if that's the way he did this. Yes, that is true. Okay. So COUT, enter GPA. CIN into the student's GPA field. You can call those fields, you can call those members. Different books call them different things. And then lastly, let's get their date. Grad year. And then CIN into students dot grad year. Once we have gathered all that information for that student, we are going to return it. So we're just returning S. We have made a student, and we're returning it. I'm going to need a prototype for input student, so make a prototype for it, paste the prototype above main. And then down here above the pause command, do this. Student S3 is equal to input student. Print S3. I'm going to remove a few spaces so that we can get all this on one page. This will not compile without me adding the input student prototype. So you'll want to do that. These are the two lines that I added, that one and that one. And then I have the rest of those. So go ahead and add the prototype for it, run it, and see if it'll let you enter a student's data. Works. All right, so I have to add the prototype. I'm just going to copy that student line, come up, paste it above main, tack a semicolon onto it. Above main. All right, I'm going to remove that CIN.ignore line. It seems to be causing a problem. Okay, that worked. Sorry about that. Take out the CIN.ignore. So you could put this into a loop. As you create your students, you could add them to an array or to a vector. You could send that entire array to a print function and it would process printing every student in turn. So really they're pretty cool. This is also how you accurately handle the idea of parallel arrays. You really shouldn't have to use parallel arrays. Instead you should use arrays of structures you create, except for the case where like you have months, you know, and then you have rainfalls. It'd be kind of silly to make a structure that had both a month name and then a rainfall amount, maybe. Anyways, everybody got this running? If you got a syntax error, let me know. All right, what I want you to do for homework, and this will probably be the last homework assignment of the semester because we're running out of time, is make a structure called book. Yeah, like we can read this. Let's oh, that's a little too big. So the structure is going to be called book, and it's going to have a string, which is the title, a string, which is the author, and then an int, which is the publication date. Then write code that allows the user to input data, to fill in a book, title, author, and pub date, and then pass that book to a print function to print the book out. Very similar to what we just did, right? You don't even have to make header files, you know. Don't worry about pragmas or whatever unless you just want to. So this will be our homework assignment. I'll write it up a little bit better, and I'll may include the sample code that we have here, but you already know how to do it. Probably should include some sample code. At least upload the sample code separately as notes. That's what I will do. So to display the contents of a structure, you need to display each field. They're calling them fields. First name is a field, last name is a field. Different languages tend to call them different things, usually in the dot operator. If you want to print the person out, you don't print it by using the variable name. I didn't print out S. Instead, I printed out S.firstname. Here are their payments. The variable is called bill, and so they're printing out bill.student. They're printing out bill.name, bill.year in school, bill.GPA. If you want to compare two structures, you have to compare them on a field-by-field basis. You can't just say if structure 1 is equal to structure 2. Instead, you have to compare every one of those. So you can write a function that will do that. Let's tack that on, and that'll be the last thing that we do. Let's make a function. It's going to be a bool because it's going to return a true or a false based on whether the students are the same now or not. And call it compare. And we are going to compare one student with a second student, S1 and S2. At the bottom of it, it's going to say return true. So if we cannot prove it false, we're going to return true. But then we're going to start comparing. If student 1's first name is not equal to student 2's first name, return false. There are more efficient ways of doing this. If student 1 last name is not equal to student 2 last name, return false. And do the same for year, grad year, and GPA. If student 1 grad year is not equal to student 2 grad year, return false. If student 1 GPA is not equal to student 2 GPA, return false. Add a prototype for this function. So go ahead and copy the function name, the header for it, and go and paste it above main. You may ask, well, why aren't you just writing all these above main? Because ideally, we would then stick all those prototypes into the header file, and we would move all of this code into a separate CPP file. I'm going to do that now. I'm going to come up here and add the prototype for the compare function. Now above, I'm going to cut and paste this so that it's the first thing right after the main. You don't have to do that. I just want to keep it all on the screen at the same time. Put an if statement here. If compare S1 and S2 and S3, then let's print a message out. Cout S2 is the same as S3/n. Else cout S2 is not the same as S3. So if we enter our data exactly the way the second student looks, we'll get the message that it's the same. But if we don't, we won't. Okay, so this time I'm going to make it match exactly. Let me do this just to make sure it works, and then I'll bring up the screen again. The first name is Joe, exact match. Last name is Jackson, GPA is 3.9, and the grad year is 2017. It should say they're the same. S2 is the same as S3. Very good. If I run it a second time and I enter different data, Bob, Bobby, GPA 2, grad year 2001, it says they are not the same. We probably could have given the function a better name than compare. Typically when you do compare, you're supposed to return a 0 if they match and a non-zero value if they don't. We should have called it something like equals, in my opinion, but we could check to see what their recommendation is. They don't even bother. We wrote all that, and here's the only thing that they said about it. You cannot compare structure variables directly. This won't work. You can't say if S1 equals S2. But you can do this, if student1.firstname equals student2.firstname, and so on. But you have to check all the fields that you care about, and that's why we put it in a function to make it easy to do. All right, we are done if you can get this to work. However, if you can get it to work, why not take those prototypes and paste them into your header file instead, just to make it look cleaner. Do that while I'm making your Dropbox. So that was short assignment Q. Go ahead and put it into Q. And the homework, the book class, is homework 12, which we will make due Wednesday of next week. Really can't be too much later than that. All right, and once you get Q uploaded, then you're done. So the reason we're making it due Wednesday rather than Monday is just so that please try to do it over the weekend, and if you can't get it done, then we'll answer questions about it.
When you said that the function, you said, what about function put in the header?
Click that, show me what error, what line it's on. Ooh.
Oh, need this?
We need that. We need that line. Can you undo it or paste it or something?
Yeah, what line do we need?
Whatever was there. Whatever was before that. I think it was called input. Let's go look. There. We need that.
Yeah.
You accidentally cut it when making a prototype. Oh, but we don't need it twice. Oh, what's happened? This is part of main.
Is this good
So,
idea?
you too.
So this.
Just grab these braces too. Go back to main. Paste them. Put it twice. Sorry, I made that confusing when I was scrolling up and down. Get rid of those